Hi everyone, and welcome to the next part of your analysis unit at Advanced Higher Computing Science. Today what we're going to be focusing on is looking at planning in terms of scheduling, resources and Gantt charts. So we're really going to be looking at project management today, and basically what project management is the process of planning and controlling everything that happens within an actual project. We're going to be looking at the features that are required, and the budget available, the quality that you want to be output. Now, depending on if you're working on a project yourself or whether you're part of an organisation like a software development company, projects are going to look very, very different. So it's defined by basically what you want to achieve, what objectives there are, which is usually based on some requirement specification that's been laid out by a client. And then if there's any agreed timescale or budget, is obviously really important to consider before taking on a project and starting to implement it or design it. So when you are creating a project, it's really important to remember that you've got four main constraints that you need to stick by. We've got, first of all, time. Now, obviously, if there's an agreed time frame or a time that the client needs this by, then that's really important, and you need to make sure that everything is based around trying to get stuff done by the end of that time frame. You've also got costs, so quite a lot of the time there'll be an agreed cost at the beginning of a project after you've worked out how much time you think you're going to need as part of your feasibility that we were looking at last week. We've then got scope. So the scope is like how many requirements or what the requirement specification actually is, And then lastly, you've got quality. So you could obviously meet all of the points on your requirement specification as part of your scope, but the quality with which you meet that can change based on the type of project you're creating and the time constraints you might have. Now, what's really important to remember that is if you are adjusting any of these four aspects, it will have an immediate impact on the other ones. For example, if we decided we wanted to decrease the cost of a project, that triangle might change to look like this. So the cost is reduced, the time is reduced, and the scope is also reduced. So we're being able to do less. The easiest way to reduce the cost of a project is to spend less time doing it. So you have to pay less time for the workers to actually create, especially if it's in software development, because a lot of the time they have the tools they need and it's just manpower that you're paying for. But obviously it could change. So if you maybe it was time you were worrying about, but you needed something done really quickly and you wanted most of the scope, you might change that so the cost has greatly improved. So the triangle can change. It doesn't have to stay a consistent size, but just remember that any side of the triangle or any aspect that you change will have an immediate impact on the rest. A lot of the time in agile software development processes, what happens is the time and the cost is decided and fixed at the beginning of a project, and that's why you have constant communication with the client so they can decide the scope, what requirements you do definitely want to be involved and what others they might be able to leave, and the quality with which everything's finished to. So you're trying to keep to the time and the cost deadlines and then change the scope and the quality as and when required. So when you're the project manager, your biggest task really is going to be looking at scheduling. And scheduling is when you take your requirement specification and you think about how you're actually going to complete a project, from analysis right the way through to testing and evaluation. And usually what happens is they will create something like this, which is called a work breakdown structure. And you can see on the right, there is an example of a website, I presume, that's being made. And it's got all the kind of different parts of that needs to be considered. Obviously a small part of it, not the whole thing. But it's got all the tasks broken down. And next to that, you can see what's called the effort. Now, they've broken the effort down into days. Depending on the size and scope of your project, you might break your effort down into hours, or it could even be weeks or months, just depending on what it is that you're creating. Once you've created this work breakdown structure, you can then allocate time, resources, people, software, hardware to each individual task and effectively create a big to-do list of everything that needs to be completed, making sure that you've got everything listed in a hierarchical order of importance so that nothing gets missed, and the most important things are completed first, or at least are very easy to recognise. And then obviously you know if you're keeping on track or not by how many days or hours or weeks behind you are. Now, what you can do, or what some important points for consideration when you're scheduling are these three things. So sequencing is really important because you have what is called interdependencies between different tasks within your project. A good example of that for us is that we shouldn't really start designing a project until we've completed the analysis stage. So we've done our feasibility studies, we've done our scheduling, we've worked out whether we can do it within the time, to our cost constraints, all that type of stuff. and then we continue with the design stage. That's called an interdependency between different tasks. We can also do concurrent tasks. So for example, sometimes you can do two tasks at the same time. You might be creating a database to work with your project at the same time as maybe drawing some of the images you're going to use for a game. Okay, so concurrent tasks can happen at the same time. However, one thing you have to be very careful of with concurrency is also outside resources. So just because something could be completed at the same time, you have to also consider whether the similar pieces of equipment, hardware, software, or specific personnel might be required. So if you had the graphics team of a software development company working on creating the sprites for a game, they couldn't also be working on the level design at the same time. So they need to have time to be able to make sure that all works. So scheduling is really important, and those are three common terms that you'll see with regards to scheduling and planning. Okay, Gantt charts are really important because what they do is allow us to look at our work breakdown structure against an official timeline. And it's really easy to see a number of things on a Gantt chart because it's quite graphical. So you can see the start and end of each activity that needs to take place. You can see how long it's usually scheduled to take. So across the top, it will usually signify the same type of effort that you did in your work breakdown structure. So if you did hours or days or months or weeks, then it would usually apply the same. Where activities can overlap with each other, it should be fairly easy to see from the graphics. And the start and end dates for the whole project are really easy to see on a Gantt chart. Now, Gantt charts can be made on a couple of different platforms. Usually for us, what we tend to do is create it on something simple like Microsoft Word or Microsoft Excel, where we can basically lay it out in a nice kind of table format. But you do also get a lot of project planning software. Some of these are free online, or some of them are available from different types of companies that you can buy, and they can allow you to lay out your project too. Just got a lot of the kind of tools that you might require to create some of the aspects of a Gantt chart. Okay, now two important things about a Gantt chart are these following terms. We've got critical paths and flow. Now, what a critical path is basically a pathway through the project where if there's any delay in the main critical path, it will involve there being a whole delay with the whole project. So basically the end point, the end duration would be extended. So it would be running late effectively, okay? It's easy to identify the critical path usually because there is lots of interdependencies and each task will rely on the task before in order for it to be completed. And usually on a Gantt chart, they're quite easy to see. They're maybe allocated in colour, or you can see some arrows to allow you see your progression through the main part of the project. You also get something called floats, and the floats are the tasks that we're able to run concurrently. So they don't have to be part of the critical path. There's a little bit of flexibility around when they can be scheduled. They tend to be scheduled around when the availability of resources are, or specific people that need to be able to work on them. And it's based around the critical path where there's perhaps less resources being used as part of that main one. Let's have a look at what that looks like as a real example, okay? So the top one is a simplistic Gantt chart created in Microsoft Word, and the bottom one is an example of a Gantt chart created in a project planning piece of software. But you can see there's some similarities. So on the left-hand side, you've got a list of your requirement specification or your work breakdown structure of everything that needs to be completed. On the top one, you can see the effort that's built in there. On the bottom one, you can see the effort is shown by the length of the lines, which I suppose is also done in the top one, okay? But you can see that it's got Monday, Tuesday, Wednesday, Thursday listed down, showing you that that's days, okay? So the first content development is done in 1.5 days, theoretically, all right? Sometimes on these, what you also get is in here, or in here, you also get a bit about interdependencies. So for example, task 2 here has an interdependency on task 1. It cannot be started until task 1 is gathered. You can't establish design until you've gathered the user requirements. Task 3 has an interdependency on task 2 being done, or I suppose 1 and 2, but by default, if you say 2, then it has 1 as well. Okay. Now the red lines here is what is called your critical path. Okay, so that is what happens. If any of them gets delayed by 1 day, if this takes us 8 days instead of 7, the whole project will gain a day. Okay, this part in green here is your float. So you can see there's a kind of day leeway there, so this can move back and forward a little bit. Okay, it might still have some interdependency, so you still can't create the content until you've done stage 1 and 2. Okay, but it can float within this section, so it could get started a day later or obviously if there's a little bit more scope, then it might be able to get moved a little bit. Underneath, I suppose you can see in this one a bit more of an example. So here's your critical path here. The arrows are showing where that main critical path is. So if any of that is delayed, the whole project will be delayed. But there's a lot more smaller floats that are going on that might be able to happen in different parts. But we do have some interdependencies here. So the analysis of the print quotes can't be done until the research has already been done. But there's a gap in space, so there's time for things to get changed, okay? I'm also guessing on this one that perhaps this blue band maybe represents stuff that's already maybe in the process of being doing, and you've also got tick boxes down the left, which is quite nice, to show what has been completed, which is really useful for the project manager, who would be the person overseeing everything that's happening. The project manager's main job is to basically evaluate the project while it's running to make sure that it is on time, to budget, and that we're following this plan that we've made at the beginning. Now, as part of your project, you're going to be your own project manager. So you will have to create your work breakdown structure, your Gantt chart, and make sure that you are following to what it is that you've said you're going to do, and you're trying to keep to your timings, which is really difficult. I think probably one of the things that most of my students have struggled with over the last few years, okay? Project manager will be using the work breakdown structure or the Gantt chart to make sure the progress is on schedule and that you're not falling behind. And also to make sure that if there's any teams that require additional help as part of a bigger company, they can allocate resources and move people between different places if they're struggling, okay? Also, what they will do is refer back to something called a project backlog, which is basically just effectively a checklist of the goals and things that need to be completed, and they'll check them off. And this is known as goal tracking. So just in case you see any of these terms when you're reading bits of information, there's terms that you might have seen, and that's basically what they all mean. Okay, so that brings us on to your task for this week. Now, this week's going to be split up into two halves again. The start of the week, I want you to focus on theory, and the second half of the week, I'm going to get you doing some practical, creating some Gantt charts. So what I want you to do first of all is log into your Scholar accounts, and under the web section, because remember I've said software development, web and databases are all the same for analysis, I want you to complete, read and fill out end of like sort of section quizzes or activities for sections 1.1, 1.2 and 1.3. So the introduction to analysis and the feasibility studies and user surveys we were looking at last week, or the last couple of weeks. And then what I want you to do is have a go at the planning section that we've looked at today. Okay, and leave the rest, and we'll have a look at that next week. Then what you're going to do is I've provided you with a document to have a little read over, which is, I think, a little bit more detailed perhaps than the stuff that you'll find on Scholar, but it is from them. So I want you to have a little read over that and then answer some more detailed questions, just so I can get an idea if you've understood everything that I've talked about in the PowerPoint, but hopefully having the document there will also help if you want to read up on any of it again. Okay, so answer those questions, submit the questions and do the Scholar work online, and then on Wednesday I will send out your instructions for creating your Gantt chart. Okay, any questions, pop me a message and I'll speak to you guys soon. Bye.